In section 7.4, we're going to look at a couple of different examples of developing quadratic equations to solve a story problem. So the first question we're looking at now is the type of question, an area problem. So in the example here, it says the owner of a new home would like to construct a rectangular driveway surrounded by a paving stone border on three sides. So all this here, this side, across here, and down there will be paving stones surrounding the driveway. And the driveway has dimensions of 25 feet by 12 feet. The pavement in the driveway represents an area of 240 square feet. So in here, this 240 feet squared. So we're asked two questions here now. First, determine the area, or determine the quadratic equation that models the area of the driveway. And then use it to determine the width of the paving stone. So first we need to find an equation that represents the area of the driveway. And then we have to find out what is this value of x. How wide is the paving stone going around the driveway? Well, we know the driveway area is a rectangle. So area is length times width. We know the area is going to be 240 feet squared because we're told that in the question. So the length of the driveway, it's not 12. Okay, it's 12 feet including the paving stone. So it's 12. But if you took away this x and then took away this width over here, which is x, you'd be left with your measurement. So the width, the inside width here, the gray, is going to be 12 feet. Take away this part and that part, or take away 2x's. So it's 12, subtract 2x. And your width is similar. It's 25 feet, including the whole stretch here. But your driveway is not 25 feet. You have to remove this distance here from this length, which is x. So your length is 25 feet, but go back x feet. So take this much off right here. Now if we multiply that out, so I'll pause it here, and when you come back you'll see it's multiplied out and simplified down to a quadratic function. Okay, now I've multiplied out the two brackets here, and this is what it should simplify down to. And we're going to solve now for x. So bring the 240 over, so it will be 0. 300, subtract 240x minus 62x plus 2x squared equals, I'll fix that in a second, equals 60. I'm sorry, that's not supposed to be an x there. So it's just 240. So 300 take away 240 is 60 minus 62x plus 2x squared. Now I'll write this the way you're used to seeing it, with the x squared term, then the 62x plus 60. It won't make any difference to how it's solved, but you may find it easier to look at it this way. Now you could use quadratic equation. What I'm going to do here is I'm going to factor first. And I can remove a common factor 2, so everything is divided by 2. So x squared minus 31x plus 30. And two factors of 30 that would add to give us negative 31. So two factors of our last number, they're going to add to give us our middle number here. And two factors of 30 are 1 and 30. And to get them to add to a negative 31, I'll make both a negative. Now I'll put a line down. So x minus 1 equals 0. X equals 1. X minus 30 equals 0. X equals 30. Now we need to think about the context of the problem. We're going to reject the 30 because up here it's 12 feet, including the two X's on either side. So they can't be 30 and 30. That would make 60 feet just for the width of the crushed stone. You're only supposed to have 12 feet maximum. So the width of the crushed stone is 1 foot. So we came up with our equation. That was for the width, and that was here. And then we used that to solve for X. So the width of the crush stone is 1 foot.